Hello friends, this video on probability part 13 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 12. I will introduce a new topic called independent events. Two events are called independent events if the probability of occurrence of one is not impacted by the occurrence of other. Such events are called independent events. Example, when you throw a coin, so you throw a coin twice, right? C1 and C2. Or the same coins you throw twice, you say that probability of getting head in second coin, if you see, is independent of probability of getting head in first coin. So if you see that probability of getting head or tail in first coin is independent of probability of getting head or tail in second coin. Both are independent actually, they don't matter actually. If you want to write conditional probability here, probability of getting head in second coin given probability given, let's suppose, given that first coin is head, this is as good as this guy. Doesn't matter, right? You see, right? Doesn't matter. So these two are independent events because their occurrences are totally independent. Getting heads in first coin, getting heads in second coin, both are independent. Doesn't matter if you're throwing one coin twice. In the first coin, whatever you get, and in the second coin, whatever you get, both are independent. They don't matter each other, right? Also, for example, if you have a jar, in this jar, you have, let's suppose, 4 red balls or 4 spherical balls and let's suppose 3 cuboidal structure, right? So you replace, you take out something and you replace, then probability of getting the spherical in the first and spherical in the second try is all same because you are replacing it, right? So you take out something and you replace back, again you take out something, so in every time the probability is same. So they are all independent events. But now in this case, if you don't replace, in that case they are not independent because if in first case if it is red, there's a spherical ball, in the second case the probability will change based on the first object, right? So that is a not independent state, but if you are replacing it, this becomes an independent event. So independent events are two events which are not related to each other. I mean, the occurrence of one is not impacting the occurrence of another. We'll see a mathematical definition for independent events. Two events are independent events, E and F, if probability of F given condition E is equal to probability of F, probability of E is not equal to 0, and probability of E given condition F is equal to probability of E. So that means probability of F is not impacted, occurrence of F is not impacted with the condition E. Occurrence of E is not impacted with the condition F because this is equal. This is equal. That's the mathematical definition of independent events. Correct. So with this, if you see, you draw one more conclusion that you'll draw one more conclusion. Let me take that in the next slide. So the new conclusion which I draw is this guy. Probability of E and F is nothing but probability of E into probability of F because they are independent events. If you see how I got it, because I have this formula, probability of E given F is nothing but probability of E. Probability of E given F is nothing but probability of E intersection F by probability of F is equal to probability of E. So if we solve this further, this is nothing but probability of E and F is nothing but probability of E into probability of F. And this is true only for independent events. Correct? So I can say that two events are independent if probability of E and F are equal to probability of E into probability of F. That is true. In that case, my events are independent. We'll take some examples of independent events. I have been told that probability of A is 3 by 5, probability of B is 1 by 5. We have to find probability of A and B. If A and B are independent events, very simple, I know the formula. Probability of A and B is nothing but probability of A into probability of B. If they are independent, we are told it is independent. That means probability of A is 3 by 5 into probability of B is 1 by 5. What you get is 3 by 25. And that is my answer. So probability of A and B is 3 by 25. Now, a lot of students get confused with independent events and mutually exclusive events. So I'll take this, I'll explain what is the difference. The first difference is the independent event, if you see, is defined for probability of events. That is, in event A occurrence is not dependent on event B occurrence. But when we talk about mutual exclusive, it is defined for subset of a sample space. For example, you throw a die, right? You throw a die, and then you get 1, 2, 3, 4, 5, 6. You have, let's suppose, event E, which has all odd outcome. So you get event E as 1, 3, 5. You have event F that has even outcome, 2, 4, 6. So here, if you see, they are mutually exclusive because there is no element common between these, right? So when I'm talking about mutually exclusive events, I'm talking about the common element between two subsets, right? So if I have two event sets and there is no common element between these two sets, I call that they are mutually exclusive events, correct? So when I talk about mutually exclusive events, I talk about sets, right? And I talk about the fact that there is no common element between these two sets. When we talk about independent events, we talk about something like that. You throw, as I told, right, coins twice, and you talk about getting a head in second toss and getting a head in first toss. Both are independent, right? Head in first toss, head in second toss, both are independent. There we don't talk about the sets or the common element in the set. We talk about that occurrence of a particular event is whether dependent or independent on another event. Moreover, mutual exclusive events never has an outcome common. If you see, if there are two independent events, there are two mutual exclusive events, there is no common outcome, right? If you see 1, 3, 5 is the outcome in this, 2, 4, 6 is the common outcome in this. No common outcome, but independent events may have common outcome. For example, when I say getting head in second trial and getting head in first trial, right? If you throw a coin twice, the first event is, let's suppose, event 1 is getting head in first trial, you get head, tail and head. This is my first event. The second was getting head in second trial, so that becomes tail head and head, right? So there are two events and they are all independent events because this guy is getting head in first trial, getting tail in first trial, and by logic we know that both are independent because the occurrence of this guy is not dependent on this guy. And if you see that, there is a common element. So a common element may occur. Please note, it is not necessary that it should occur, but it may occur. So if there are two independent events, they may have a common element, but for two mutually exclusive events, it will never have a common element. The third point is, two independent events having non-zero probability of occurrence cannot be mutually exclusive. Conversely, two mutually exclusive events cannot be independent. That is, if my sets are mutually mutually exclusive events, they can't be independent, and other way around. If it has some elements. For example, why I'm telling you this is because if my E and F are mutually exclusive events, then my E intersection F is nothing but phi. There is no element in this. Example, in this case, if you see, if E and F are mutually exclusive, for mutual exclusive, there is no common element in this, right? But if E and F are independent event, this is nothing but probability of E and F, I'm saying. EF are a mutual exclusive agreement, this becomes probability of E into probability of F, right? So probability of E and F is nothing but probability of E into probability of F for independent events. So if it has non-zero values, that means it has some numbers, correct? If you see, if they are not zero, if they are non-zero, P, E and P, if are non-zero, it has some value. That means the set will have some numbers, right? Some beta it will have. So thus, if a set is mutually exclusive, it won't be independent. If it is independent, it won't be mutually exclusive, correct? And please let me focus once again. The approach is different. When you talk about independent event, I'm talking about it's logical. Independent event is more of the logical thing, where logically you think whether one particular event, occurrence of one particular event is dependent or independent on occurrence of another event. It's a logical thing. When you talk about mutually exclusive things, you end up getting the sets and check if there is a common element or not. If there is no common element between two sets, in that case they are mutually exclusive, right? We'll have a mathematical definition for independent events which has 3 terms. So for 2 terms I knew that probability of A and B was probability of A dot probability of B. For 3 terms similarly, if A, B, C are mutually independent, probability of A and B and C is nothing but probability of A into probability of B into probability of C. Same formula. We'll take one example. A die is thrown. If E is the event, the number appearing is a multiple of 3. F is the event, number appearing is even. Then find whether E and F are independent. So I have a die that is thrown, right? E is the set which says the number appearing is a multiple of 3, that is 3 and C. E will have 3 and 6. F is the number appearing is even, that is 2, 4 and 6, right? I have to find whether it is independent or not, correct? How to find? If I can prove that probability of E and F is equal to probability of E into probability of F, that means it is independent, correct? So what will E and F will have? This guy will have element 6, that's the only common element. So probability of E and F will be 1 by 6, because the total sample space will have 1, 2, 3, 4, 5, 6 elements. 1 by 6. And probability of E will have 2 by 6. Why? Because 2 element in E by 6. And F will have 3, probability of F will be 3 by 6 because F has 3 elements by total number of elements. So if you see, both LHS and RHS are equal, thus I can say that it is independent, right? It is independent. Yes. Is it mutually exclusive? No. Why? Because independent, so it won't be mutually exclusive. Also, if you see E and F, there is a common element. Since there is a common element, you can say that it is not mutually exclusive. For this to be mutually exclusive, E and F has to be 0, right? Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.